As usual, read this on your own. I'll start talking about it. Pause it to give yourself a moment to see what's going on in here. Jared has volunteered 50 hours and plans to continue volunteering 3 hours each week. Clementine has just started volunteering 5 hours per week. And if she has just started, that means she doesn't have any volunteer hours in, which makes her different from Jared. Find the number of weeks in which Jared and Clementine will both have volunteered the same number of hours. Now, before you get down this path where you're thinking well, Jared is the variable and Clementine's the variable, let's list what we know about the two of them. I'll set this over to this side, though. I don't think that's 100% necessary. I'm just doing it for those who would like to see it. But I do think it's helpful to define your variables. Find the number of weeks. Well, let's let that be x. And then the hours would be y. So we're looking for, how many hours they both have the same. And just like the last one, this one lends itself to the whole slope formula deal. So with Jared, he's gaining 3 every week, but beginning with 50. For Clementine, she is gaining based on a starting point of nothing, so I'll write plus 0 just temporarily, but we do know that 5x would be how quickly her rate is changing. Go ahead and pause this video and see if you can figure it out from here. Alright, I will get to the next step. So you would really know when are Jared's hours going to be the same as Clementine's hours. Which means, when will 3x plus 50 equal 5x? Now this is a pretty easy one to solve, so from here on out you're on your own. Pause this video, compare it with what I put. Once you solve this, you'll find that x is 25 weeks. Just like last time, there's no reason to put xy equals 25, comma, but it's good to always do it out of habit. And so if I do 25 times 5, I get 125. If I check it in the other equation, 3 times 25 is 75, and 50 gives me 125. And we already have it summarized over here, so that's more than enough, but maybe it would be nice to work and write this out with the whole word, 25 weeks. And if we look at the real world problem, let's make sure nothing insane happened. Well, 50, 25 times 3, somebody else is starting 5 hours a week. It doesn't seem like a number like 1 trillion weeks or anything, so this seems like a reasonable answer. Okay, so in this section, you're applying systems of equations, but that's mostly focused on what's better, graphing, elimination, or substitution, and then there's going to be more real-world problems, which now you've seen quite a bit of in the earlier sections of this chapter.